Hello. So in this tutorial, I'm going to be going over how I made the palette swapping lighting shader for my upcoming game Trash Quest. This is an example of what you can use the palette shader for. So right now, I've got a black and white level being palette swapped into a CJ color palette. We could do other things. We could make, the foreground or the background really white, have like a kind of inverted look to it. This is what I'll be showing you how to do. All right, let's get into it. Okay, so what I've got here is an old project that we're going to be repurposing for this tutorial. I've stripped out all of the old art and I've put in a new kind of 1-bit aesthetic, because I think that'll be the kind of the easiest way to describe what's going on in this shader. So this might seem a little bit like it's not related, but the first step we're going to do is we're going to do something that's going to get rid of, so it's kind of zoomed in here, but basically if you see here, we've got these nice big chunky pixels, but then when the player's coming through, that trail that he's leaving behind, it's not quite as pixelated. It's still pixels because like everything's made of pixels, but it's not the same pixels that everything else is. We've got big nice chunky ones, and the player's just like, yeah, I don't care about pixels. Pixels can go jump for all I care. So we're going to be doing something that will hopefully fix that up. Okay, so to do that, we're going to use what's called a render texture. So I've got a new folder here called materials. I'm going to create a render texture. The resolution of my game is 480 by 270. We want to set this to point so that it's nice and pixel. No smoothing here. And the other thing we're going to do is going to create a material that's going to have this render texture as a texture. So I'll call this render text material. Probably just call this something nicer. Text, so they both match. So we'll use unlit texture, and then we'll drag this render texture into the texture field. So that's step one. Next step is to get our main camera, and the output settings, there's a target texture here. We want that to be our render texture, so we'll drag our render texture into target texture. Next step, beneath our main camera, we'll create another camera, a camera. We'll call this pixel camera, and we'll use the same settings. Can I copy component, and then we'll paste component values. Everything except for the render texture. So we don't want this to be going to the render texture. So just create a nasty loop. We don't want that. Okay. So we've got this set up. It's using the same size, orthographic, solid color background, all good. Let's go out into our 3D mode so we can actually see what's happening. Set this to perspective. Okay, here we go. So this is our main camera. Well, that's our main camera. This is our pixel camera. We're going to offset it, so we're going to set it back by another 5 units. Now, under our pixel camera, we're going to create a 3D object. It's going to be a quad. And this quad, set this forward a little bit so that it's not pressing right up against our camera. This quad is going to have our render texture applied to it. So we'll grab our render texture material and apply it to this quad. And you can see here that what this camera is seeing is what's being put onto this quad here. So what's going to happen is that we've basically got this kind of chain where this camera sees the game and sends it to this quad, and this camera sees this quad and sends it to the screen. It's not going to work right now because you can see it's very small. You can barely see it in the middle. There it is, compared to the actual screen, which is much bigger. So we need to get it to be the right size. Now, setting the vertical size is going to be fairly easy. So that's going to be our size is our y, and then we times that by 2. And our scale, the scale x is a little bit trickier. It's our new value, and our ratio is 16 by 9, so it means we need to take this, we need to divide it by 9, and we need to times that by 16, and that should get us something that is the same. Yeah, see, look how nicely those corners are matching up. Oh, that's the stuff I love to see. Yes, 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 yes. Oh, lovely. Okay. So yeah, just take your size, times it by 2 for the y, then take your y, divide by 9, times by 16. Assuming you've got a 16 by 9 ratio, you probably do. If you don't, just do those same steps, but swap out the numbers I use for whatever your ratio is. Okay, so now when we play, you should see that. Yeah, look how nice and pixely that trail is. Oh, that's the good stuff. So I'll zoom in a little bit further again, down to ×2. Yeah, look at that trail. That's what you like to see. Nice and pixely. Okay. That seems completely unrelated to what we're doing, but trust me, it will come back. It's a really nice thing to have. I use it for all my projects because I don't like the look of mixed pixel scales, especially high res mixed with pixel. I do not like. So I do this for all my projects, so it means that all of my particles and trails and everything like that will all be aligned to the pixel scale of the art. All right, so it does also assume that you've calculated what this should be. You know, there'll be articles online about setting your camera size for whatever your pixel art scale is. I'm not going to go into that right now because it's math. Okay, so the next step is to create our shaders. So what we're going to be doing is we're going to create a subgraph that is going to take the colors that we have and map them to the colors that we want. So right now what we have is we have black and we have white. And what we'll be able to do with the color mapper is we'll be able to take those two colors and map them to pretty much anything. So let's do that. So we'll create, actually, there's a few steps we need to cover first. If you haven't, open the package manager and make sure you have the universal render pipeline installed. You'll definitely need that. And the other thing you need is shader graph. So if you don't have those two installed, make sure you install them. Where my remove button is, there would be an install button. If you don't have them, install them. Fantastic. And then up in assets, you can really put this wherever. I tend to put it in assets. You need to go create, rendering, universal render pipeline. It's off the screen. Okay, I'll do it over here so we can see. Create, rendering, universal render pipeline, and then pipeline asset. Just leave it whatever it's called, it's fine. Project settings, if you don't have project settings, go to edit, project settings. That'll bring up probably a window. You can dock it like I have, or you can just close it when you don't need it. You want to go to the graphics tab, and then for this field here, you want to drag in the first of these new objects. Now you're set up for the universal render pipeline, and we are good to go. Okay, so what was I saying before about the shaders? Okay, so we're going to create a subgraph that will map our current colors to our target colors, and then we will create a shader that will take that subgraph and apply it to our scene. So to start off with, we're going to create a shader subgraph. Call this one color mapper. Double click it to edit it. So our output is by default set to vector 4. I think that's fine. That's what we want. Yes, that's what we want. So we need to set our inputs. So we'll need a texture 2D. We'll give that a default setting so we can set it up nicely. And then we'll have two other fields that are colors, and that'll be target color 1, and you can press Control D here to duplicate that, or just create another color, target color 2. Okay, so we'll drag our texture into the scene. It's not really a scene, is it? We'll into the graph, and we now need to create a sample texture 2D. Drag our input texture into that, and we can see this is what it thinks it looks like. It's done a little bit of hocus pocus around what the edges actually look like, because this is a sprite, not a texture, but it'll be enough for what we need to do. So the next step will be to start mapping the colors from this to our target colors. So first step we need to do is we need to create a node that is called color mask. So we create it. Okay, that was nothing. Color mask, there it is. So the input of the color mask will be our texture, and the color mask color will be whatever color we're trying to sample from the scene. Now, in our case, it is just a straight up, nope, that's it. Just straight black. We're gonna look at the black first, and what we'll see here is what the color mask is doing is anywhere in our texture that has black, it's sampling that, and in our mask, it's making that white. So it's basically finding all of the bits that are the color of this input color here, and it's making them white, and everything else will be black. Now, to make that into what we want it to be, we're going to have another node called multiply. Now we'll have the output of the mask come in here. It'll give us those whites, and then white, we can multiply that by anything to get what we want it to be. So we will drag in our target color 1, and that will be onto B. Now at the moment, it's set by default to black, so it doesn't really look a whole lot like anything, but we can make that, let's, so we can still see it, but it looks a little bit different. Let's make it a dark blue. Okay, so you can see here we've got the blacks are getting picked up by this and turned to white, and then they're being multiplied by whatever our target color 1 is, and we've got these nice dark blues. Alright, so basically we're just going to do that all again. Press Control D, and yep, everything is as it should be. We'll replace, dang it. Okay, and now I'll just replace target color 1 with target color 2. There we go. And the other thing we want to do is we want to take this, and now this is going to be our white. So in the scene we've got black and we've got white. And this is another point. It's not picking up all of the white. There's a little bit of furriness around Unity's color detection. So you just want to grab this range and just push it up just a little bit. So 0.1 will do. I'll change it up here as well just for consistency. And now you can see all of the bits that are white over here, it's picked up, and it's missed out any of the transparency, none of the blue, none of anything else. It's just picked up the whites. And we can set it to our target color over here. Let's make that by default a light blue. So you can see we've got a dark blue and a light blue. And now what we need to do is we need to combine these together so we can output them. So to add them together, there is a nice node called add. And we can go output from here, output from there. They've been combined together. And now the output from that will be going into our output for the subgraph. And that's pretty much all there is to it. If you wanted to make it so that there were a bunch more colors, because maybe you don't want to do just a 1-bit black and white, maybe you want to do 2-bit with 4 colors or something like that, that's fine. Just again, copy this step. Oops. Just grab those, duplicate them out, pick a new color here, pick a new color here. You'd probably have more input colors here if you were doing that. And then when it comes time to do it, what you just need to do is duplicate this one here, and it just kind of cascades down. So instead of being just the 2 of those going into the one, you have the output of the top one going into the multipliers output. So you've kind of just chaining them together, and then you would have the output of this going to the output of the subgraph. And you can have that going down as far as you want. Like, you can just keep chaining them together, as many colors as you want to do. Again, for now, I'm just keeping it simple, just a nice 2-color scheme. Delete all of that. Hook this up again. All right, so that is our subgraph. I'll save that asset. And now we're ready to start using it. Okay, so next step is we're going to create a shader, blank shader graph. This is going to be our palette shader. Double click that to edit it. Set our graph settings to begin with. I'll make this universal. Fantastic, that's too much stuff. So we want this to be unlit. So we don't need to worry about any of these. That's all fine. We're working really in 2D, so we don't have to care about any of this. We're only really caring about the base color. So what we're going to do is we're going to drag in our color mapper, and we're going to have a texture 2D, but the difference here is we're going to call this main text, and then click on that so we get the settings, and we'll also give us a reference name of main text with an underscore in front of it. And you want to make sure that underscore's there and it's capitalized the same. This is a special thing that Unity is looking for, that will let it know that this is the main texture of the material. And we'll also get our colors. So target color 1 and target color 2. We'll drag this in so that's the input to here. Drag both of these in so it's the input down here. Now it might seem a little bit wasteful at the moment to have made a subgraph and then just essentially redone all of the same inputs and outputs for this step, but trust me, we'll get to that later. We're going to do some cool stuff with it. For now, we're just going to hooking it all up and making sure it works. Okay, so target color, let's again make it kind of blue. And our target color here, let's make it a lighter blue. Okay, that's what we're going to have to do because main texture. Oh no, yeah, we can put a default texture here. Let's do the stairs, the ground with the stairs, and yeah, we can see it's working in here. All right, fantastic. Let's save that. Now, this is why the step before with the render texture was important, is because what we can do now is, rather than applying the shader to every single object in the scene, which is going to take way too long, we can just apply the shader to this material, and we apply it once and it's going to apply it to the whole screen. So we'll find the material that we used for that. It's this render texture. Before we had it set to unlit texture. Now what we can do is we can drop down the shader, go into shader graphs, and find the one we just made called palette shader. And there it is. And you can see what we've got is it's looking at the scene and it's applying these colors to it. These are not particularly nice colors right now, so I'm going to try and make them look a little bit more pleasant. Just, there we go, a little bit purpley. And then the light color, that's probably okay, actually. It's not that bad. A little more, yeah, that'll do. Now if we hit play on the scene, we're a bit zoomed in, aren't we? But you can see here we've got our entire screen is now looking like the two colors that we've mapped it to. So in reality, let's make that noise stop. Okay, so in reality, a scene still looks like this. Whoop. There we are. Kind of got a few things in the way, but it's all that black and white. But the part that we're looking at is this bit here, and it's got these this material applied to it, and it's changing the palette. And you can do a bunch of cool stuff with this, I think. So you can make it so it's just a little bit off. So if you still want to you want that kind of black and white aesthetic, you can still kind of do that, get that really dark here, and get this one really close to being white, but just not quite, it's still just a little bit off. So you kind of got the black and white aesthetic, but just with a bit more kind of pizzazz to it, a little bit more color underlying it. Makes it a little bit more easier on the eyes, I think. Instead of a stark black and white, you get a black that's a little bit pulled back from that, something like that. See, that's a it'll be much easier on the eyes for a long session. And you can also do things like have Gato Roboto that have collectibles that unlock different palettes. So you could have that as part of your game, have some sort of collectible, unlock palettes, make a game look all funky like that. You could have different color palettes of different rooms. So each time you enter a room, there's a new color, makes it more visually distinct from the rest of it. There's many things you can do with this. What I'm going to show you how to do is use this palette swapping to make pixel lighting. So what we'll do is we'll go back into our palette shader. Still using those default colors, which I'm not super happy with, but they exist and they are what they are. So we'll make 2 of these, and this can be target color 1A. Then we also want a target color 1B. And that'll be the slightly darker version of it. 2A, duplicate that out to 2B. So where this has got 1A and 1B, we'll have interesting. These still have the old names. Let's just delete them and make sure it's all right. So color 1A and 2A go into the first one. Color 1B and 2B go into the second one. For now, let's just make this a little bit darker than it currently is so that they're visually distinct. Okay, so you can see here we've got a darker version and a lighter version. Now the next thing we need to do is we need to get the position of the shader. So that will be position. And we need to compare this to the player's position, because what we want to do is we want to make a kind of circle around the player that's a lighter color than the rest of the scene. So we will add a vector 3, call that player position. We need to make sure this has a reference name, so I'll call that player position. Doesn't really matter what you call it, but make sure you remember it because we're going to need that later. We'll drag this into the scene. And so this is the position of the player, this is the position of the shader. We need to compare those two by distance. So we'll grab the distance between them. Get the outputs of these two into the inputs of this one. And now we have a distance, and we need to have a value that determines how far away from the player the shader should start using the darker color, where that boundary will be. So we'll call that, that will be a float, and we'll call that threshold. And now what we need to do is we need to compare. So a comparison, we're going to compare the threshold with the actual distance. We want to see if they are, we want to see if it's, the actual distance is less than the threshold. If it's less than the threshold, we want to use the lighter one. If it's not, we want to use the darker one. So for that, we need to use a node called branch. So that takes in two inputs, in this case, the lighter one and the darker one. And it will choose which one of them based on the output of the comparison. So now that's going to be our output here. So let's neaten this up just a little bit so it looks a bit nicer. Actually, that's, yeah, this can come a bit closer now. Yeah, okay. So, yeah, we've got, so we have the position of the shader, we have the position of the player, we have the distance between them, we have the threshold for when we should use one or the other. We compare the distance to that threshold. If it's less than that, we use the true branch, which is the brighter one. And if it's not, we use the false branch, which is the darker one. And then that gets outputted to our base color. And that is our shader. So if we go back to our scene, we'll get it 2D, I guess. Now, there's a bit of a trick here, because if we just play or it's all, see, it's all, I want to say dark, but our colors are a bit off, so I'm just going to change it so that they're a little bit more in keeping with what we actually want it to look like. Okay, so okay, I'm gonna cut that out because there was a lot of muttering, but essentially what we have is we've got a dark version and a light version of our two colors, of our two pairs of colors. I'm gonna increase this threshold, and just we'll see how far it takes us before we start seeing a difference. All right, we're up to, oh, there it is. All right, so you can see here we've kind of got this circle that's going to spread out, and that's going to be applying, you know, we've got one pair of colors on one side and the other pair of colors on the other, but it's not exactly in line with the player. So we need to do a little bit of logic and math to get the player to tell the shader where the player is. So to do that, just stop playing here. So we'll go to our scripts folder. I have technically already made the script, but I'm going to delete it and we'll start again. It's a fairly small script. So I'm going to create a C# script. I'm going to call it Shader Manager. And open it up. We don't need the start function. Don't need that. Now we're going to need two variables. One is going to be a transform, and this is going to be the position that we're tracking, so we'll call that player pos. And the other is going to be the material that we are setting, so we'll call that material. Now on the update, what we're going to do is we're going to say in the material set the vector, and the name of this vector is whatever you call the player position reference before. So It's going to be called player position. And then the position is going to be our player pos variable position. And that's it. Let's delete those, we don't need them. Save this, and I'll head back into the project. Now, the tricky part here is that the player is here. The material, the shader, is out here. So if we have, if you can imagine that threshold value is like a sphere around the player, it's not going to reach all the way out here. If we want one that's like 3 across, this bad boy is like 14 back from the screen, so it's not going to reach. So we're going to have a second. I've made it already. I'm going to delete that so we can create it together. So we're going to create a empty game object under the player. We'll call it shader tracker. And what we're going to do is, so this is, let's just double check how far out it is. This camera is -10. This camera is -5 off of that. This plane is 1, so -10 minus 5 plus 1 is 14. So our shader tracker should be -14 back from the player. So now we have this object that we won't be able to see, but it'll be in line with the shader, and it'll be telling the shader what the position is. So onto our quad, I'm going to add our shader manager. I tell it about the player position object, which is the shader tracker. Material will be this material that we've been fiddling with. Now when we play, let's just make sure that the threshold is right. Okay, so the threshold is 0. It's going to be nothing if it's the 0. Let's make it 4. 4 seems like a nice number. So now we should have... Now we've got a nice bit of light around the player. That's going to track them through the game. And what we can do with this is we can do some stuff like maybe... like maybe you want it to look like it's black outside of where the player is. So you could grab the darker version and just really darken it up. Just it's almost nothing out there. And the lighter one, maybe make that really dark too. So it's really hard to see much other than what the player's looking at. Now this is not particularly useful for the game that we're playing right now, because I really want to see a little bit more of what's happening than just this. So we can make the lighter color a little bit lighter. Just add a little bit of lightness back in. But it still looks like, there's... We can see it, but it's quite dark out there. You could do other things with this, like maybe you could make make this the same color as this, so that it looks kind of similar. But then maybe what you could do is you could have a mid-tone. So a color mapper here, have a tone in between these, and have that one only show up when it's close by. So you could have something like this netting material here. Like, we're not actually interacting with that netting, it's this background. So maybe what you could have is a mid-tone where this material or these sprites only show up if you are close enough to them. You know what, give me 1 sec. I'll do that so we can see what it looks like. So I'll talk through it, but I might not actually. I'll leave this part in. I might just make this fast forward, but we'll see. Okay, so let's do this. Okay. So I want a third target color. Now, in my case, I'm still only going to actually be using 2 colors. but it's going to be determining. This middle one is going to kind of turn between the darker variant or the lighter variant, depending on how far away we are. So that's using color 1. That's using color 2. So I actually want this middle one to be using color 2. Bottom one will be using color 3. We want to add these in sequence, so that actually goes in there. Duplicate this. The output goes into the input of the add. The multiply goes into the other input. And then we drag this into the output. Let's save that. And now in our palette shader, we'll have one extra field that we can put in. Now, what's dark and what's light? Okay, so... So, in all cases, I want the darker color to go to the third color. But what I want the middle one to be, when we're close, I want it to be the lighter color. And when we're further away, I want it to be the darker color. Yes, so in the darker version, the darker one maps to the middle color maps to the darker one, and in the lighter version, the middle tone maps to the middle tone. Okay, cool. Let's save that. I'm going to need to update my sprite. So sprite will be which one? This one? That's going to be way too big for your screens, I think. That'll do. Import that. Okay, so I want a mid-tone. That looks like it will do. Okay, so these are all a mid-tone. File, save, export actually. Yep. And now, when we're back in here, I want to use the color of that as this color. So I'm going to color pick it from here. So that's the mid-tone now. We'll save that. We'll look back in our scene. Hopefully we should see. Yep, so this is a bit darker than the rest of it. And now when we press play, hopefully this should be obscured unless we're actually looking at it. Or unless we're actually up close. Okay. I have done the opposite. It is hidden unless we're close. I mean, that's kind of... okay, that's kind of cool too, but that's not what I wanted. Okay. Alright, let's go look at the palette shader again. Okay, that's my mistake. This color is the darker one, this is the lighter one. That's what I was messing up. This is the darker one. It should be mapped to the mid-tone. Let's save that and then play again. Here we go. Yeah, see, okay, so you can't see that, you can't see the background here, but when we get closer, yeah, now you can see it. Nice, cool and good. Alrighty. So you can see, like, there's a bunch of ways you could use a shader like this. You might have noticed that what I was saying before about not liking smooth gradients in amongst the pixels is kind of coming back. There's this I mean, there's pixels, but again, in comparison, it's smooth compared to these nice big chunky ones. So what you can do there is just everything we did before to make that to make the render texture, just do it all again. Just one extra layer of that, which will pull all of our color shaders back into line with the pixels. And there you have it. So this is an example of how I did it for my upcoming game, Trash Quest. So this is what this shader can look like in action. So I've got a couple of things going on here. I've got two layers instead of just the one. It's kind of an inner layer and an outer layer. I've got a number of colors happening. And then as an example of what you can do with this, if we come down here, when we go into different zones, I'm swapping out the colors for a different set of colors. And here's kind of an example of where we've got those kind of background things, just kind of like distant shadows that you can't really quite see. And I've got some other things going on as well, like there's some noise around the edges. There's a bit of pulsating going on. There's lots of things you can do with this kind of shader. All right. Well, thanks for tuning in. Hopefully this was some use to you. Follow me on Twitter. I'll put links in the description. This game will be on Steam soon. I'll put links in the description for that when it comes out as well. So if you're watching this, maybe a little bit into the future from when it comes out, maybe have a look at that and wishlist it. Otherwise, follow me on Twitter for updates on the game. And I hope you found this tutorial useful. All right, thanks. Bye.